Okay, well, let's begin. So we've got a webinar we're going to do today on electric transportation, in particular kind of light-duty electric trucks. I have Dr. Brooks Agnew with me, whom I've known for a couple of years. He's become a fine friend and certainly a kind of trusted colleague in this space. I've been in a test drive of his wonderful, I guess it was a prototype at the time. But anyway, Brooks, welcome.
Thank you very much. Good to be here, Craig.
All right, so we have a series of slides. I think I'm going to let you just kind of make your presentation about the vision motor cars and what is the vision, as it were. Why don't you just take us through this, and I'll just kind of chime in and ask a few questions as we go through. So you want to talk about what is the problem?
Well, yeah, this is, I have these wonderful discussions with, politicians and also business people. They want to know, can I jump in this electric car and drive from, say, Charlotte to Atlanta? And I tell them, no, you can't do that. That's not what electric cars are made for. And oftentimes you get the first response, well, gee, what the heck good is it? Why, if I can't drive it like as far as a gasoline vehicle, why is it important? And if you'll just hit the down arrow, it should bring up a photograph on there. On that screen.
Yeah, I know it should, but I don't think it is. There's certain things that graphically don't function very well here, and I'm not sure I can do that. But anyway, the picture is a huge traffic.
All right.
I happen to know.
Yeah, the picture is like 12 lanes of stop-and-go traffic around any major city that you want to think of. That's really the market for electric vehicles. The fact that there are 150 million commuters every single day currently spending $350 million a day on gasoline instead of driving the U.S. economy with their purchased dollars. Every person that's listening to this webinar or that drives to and from work or does light delivery feels that at the pump. And it's showing up on everybody's bottom line, either as a negative or as a price increase. And the other interesting thing is, up until just a little while ago, 64% of that gasoline comes from non-U.S. sources, which creates a security risk for the United States of America. And as you already know, any one of numerous factors will immediately raise the price of gasoline. You let anything happen in the Straits of Hormuz or between the difference of the dollar and the yuan or a presidential election or an oil spill, and you're going to see the price of fuel radically change. That is the problem with the American industry that has now become so dependent upon oil. Every president since Carter has made the statement that America is addicted to oil and we need to do something about it, but almost nothing has been done about it other than through the efforts of independent companies. So let's think about what really is the EV market. Is it this 300-mile range that the oil companies want us to hit, or is it something else? And fortunately, if you go to the next slide, wow, none of the graphics on this one showed up either.
So I think the problem is the way this was in PowerPoint, correct?
Yes.
And is this one of these things that advances that has?
No, there's no graphics. There's no animations on any of these pages.
Okay.
There just should be a.
Sorry about that.
I should have sent it to you as a PDF. But on this sheet is a graph that shows the driver age and the number of miles each day that those groups of drivers drive and the number of minutes that they spend on the road each day. This is a study that's done by the Department of Transportation over a 25-year period, and it determined that the average driver drives less than 38 miles round trip to work each day. Actually, it is a much higher proportion than that. And of course, in driving these 38 miles round trip each day, they produce 3 billion kilograms of CO2 every single day. So if the Department of Transportation numbers are right, then at least as far as Vision Motor Cars is concerned, since our first vehicle is a light-duty, highway-ready truck, let's go to the next slide. This is...
By the way, Brooks, in the archived version of this thing, this will all be cleared up. So just present as if everybody can see exactly what you're talking about. This, for whatever reason, this slide worked. The one before it didn't,
Okay.
but don't let that throw you.
Okay. So as far as Vision Motor Cars' first launch of the Everest light-duty electric pickup truck, we wanted to know what is the market, what's moving in U.S. auto sales. And again, these are Department of Transportation numbers. And the long story short, if you analyze these numbers, light trucks in the United States, and by light truck we mean something on the order of a Ford Ranger or the original Datsun or small Toyota trucks. We're talking about small trucks, not mid-size trucks or full-size trucks. There are about 12 million of these small trucks still on U.S. roads, and that is a $300 billion replacement market. And Vision Motor Cars is focused on penetrating 1% of that market in the next 8 years. So that's basically our market. We firmly believe that the small truck market never went away. It just became impossible for internal combustion engines to serve because of internal combustion CAFE standards. These are fuel economy standards. They became so high that the performance of a gasoline-powered engine would be curtailed to the point they felt there was not an effective market for them, and so they phased out, and in December of 2011 ended the production and sale of small trucks in the United States. So let's go to the next slide.
Well, let me ask you about that. I think we've talked about this before, but what? And that this is because of the CAFE standard. So you can't buy a 2012, F-150.
Oh yeah, an F-150 you can, but that's a full-size truck. But you can't buy a 2012 Ford Ranger. That's a small truck.
I see. And so
anything
why would go ahead?
Well, because anything with a 108-inch or less wheelbase has to get 26 mpg. They can't do it. They can do 21 and a half maybe, but they would have to go to something like a 1.5-liter turbo diesel motor to make a truck that could hit those mileage numbers, and they weren't willing to do it.
I see.
They were putting out a 6-cylinder truck that got 17 to 18 miles per gallon in town, maybe 24 miles per gallon on the highway, and they just could not meet the standard, or they chose not to meet the standard, so they just ended the line of vehicles and slowly over a period of 5 or 6 years moved everybody up to mid-size trucks like a Tacoma or a Dakota or full-size trucks. They just did that by slowly increasing the price of the small trucks to where people said, what the heck, I might as well go to a full-size truck.
I see.
But the market for small vehicles, small trucks, never went away. It's just not being served.
I see. That's very interesting. So, and this is a fairly recent change. By the way, when I introduced you, I forgot to mention probably the most important, your most important qualification, and that is instead of coming from, a serial entrepreneur, having worked in, dog food or perfume or something like that, you actually come from the auto industry. You want to tell us a little bit about your background there?
Sure. I worked 26 years in the automotive industry, ended up as a launch engineer, a Six Sigma black belt with over $500 million in completed projects. I've built manufacturing plants from the ground up, literally from the dirt to a finished plant. I've closed plants. I've relocated them nationally and internationally. I've done a tremendous amount of consulting and contract work for General Motors, Toyota, and Nissan. So those are my qualifications. I helped launch the Nissan Altima, portions of the Tier 1 launch for the Cadillac CTS and the Pontiac Solstice. So this is something that I'm used to doing, just not on an independent basis. So naturally I'm new at cutting the fat out of what is one of the fattest, most bloated industries in the world.
Okay. Very good.
So if we go to the next slide, this is a very common question that comes up with respect to electric vehicles. It's called range anxiety. It's a great card for car dealers, car manufacturers, and oil companies to play. They strike fear in the hearts of anyone. You're not going to be able to go anywhere in an electric vehicle. The Neil Cavutos of the world say they're not practical. Until you can come up with something that can recharge in 5 minutes and drive 300 miles, you're never going to be able to compete. Well, this is just nonsense, because according to the Department of Transportation Household Survey, there has not been a significant change in American driving habits in more than 20 years. It's been very, very stable. And this habit is that the average personal trip is about 10.06 miles one way, and the average commercial trip is 26.8 miles one way. And if you look at this daily driving miles, it's divided up into 4 groups: 1 to 40 miles, which you can see about 62% of the driving and public and private, I would say commercial routes, 62% fall into this category. Another 20% fall into the 41 to 75 mile class. So now you've got 82% of drivers drive 75 miles or less per day. And then another 12% will pick up the 76 to 100 miles, and only 6% drive more than 100 miles per day. Now, that's not saying you don't jump in the vehicle 3 times a year and drive to Atlanta to see your grandmother, but it's not a daily function. It is an occasional function, a quarterly function. So this really was our market. This 94% of drivers is what we shot for. And we created a vehicle that meets these performance criteria, and I think this is the range that every reasonable electric car company is trying to go for. The ones that are going for 300 miles, I don't think you'll touch their vehicles for under $100,000 for a long time. That's not a car for me. I don't know, maybe, Craig, all of your listeners can afford a $100,000 car, but I kind of doubt it.
Yeah.
Let's go to the next slide.
Yeah. Before I do, let me just mention that there are, for those 3 days a year that you want to drive halfway across the country to Grandma's house, that does open an interesting question, but there are 25 million homes in the United States alone that are multi-car families, where one of those cars drives less than 40 miles a day. So in other words, yes, there are rare occasions where people do need to go on long trips in their car, but there are 25 million multi-family. That's a lot of low-hanging fruit, if you see what I'm saying.
And I'm one of them. I have a diesel pickup that's able to pull a house uphill in a hurricane, but I don't drive it very often. I drive the electric everywhere. Yeah. So I may fill up my truck once every 2 months. Because all the short trips, to Lowe's, Home Depot, AutoZone, the grocery store, the movie theater, they're all done with the electric. Everything I do around town is done with the electric. Then if I need to drive from here to Indianapolis, then I'll break out the diesel truck. The point is it becomes a supplement to your life, and you're able to put $2,000, $3,000, $4,000 a year back in your pocket, tax-free.
Yep, good point.
So the next slide, and we hear this from time to time. You can hear it on talk radio. Sometimes you hear it on some of the business shows on the news, is that electric vehicles are more polluting than internal combustion engine vehicles because they're coal-powered. And coal is such a filthy, nasty fuel that we don't want to add any more burden to coal-fired power plants. Well, I took the liberty of going to the Department of Energy and pulling this graph up, which shows you all the sources of electricity in the United States. Only 44.9% of our electricity in the United States is generated by coal. One thing you need to know about power generation, and I have worked in that industry as well, both on the biodiesel side and on the cogeneration side, is that power plants don't shut off at night. Just because everybody goes to sleep and the air conditioners start idling and, all the plants and motors and everything that are running out there stop at night, doesn't mean you can stop water from going over the dam. It doesn't mean that you can just cool off all the boilers and let it all sit and we'll fire it up again tomorrow morning at 5 o'clock when people wake up. It doesn't work that way. You have to idle these plants all night long at somewhere less than peak capacity, which basically means about 35% of nighttime electricity generated in the United States goes unused. It's surplus electricity. We move it around the country because of a 3-hour differential, but other than that, it's idle. It isn't used. The other thing
Well,
that
let
we
me just
realized,
understand this, Brooks. So when you say it's not used, you're saying it's dumped back to ground. In other words, that somebody's burning a lump of coal, and the electrical energy that used to be chemical energy is now just dumped back to ground.
that's correct. It's
Okay.
either shunted back to ground or it's an open circuit. The generator's running and nothing's running off of it. It's like having your wall socket without anything plugged into it. There's electricity there, but you're not using it. But the power companies are paying for it. You're paying for it. Now, the interesting thing is that almost all EVs will charge up overnight. There'll be some short charges during the day because people will practice opportunity charging. But most people will plug in their EV at the end of the day, let it charge up overnight, and it'll be fresh and ready to go in the morning, which means for years and years, perhaps decades, electric vehicles will add zero net CO2 to the environment. That CO2 was already going to be spent. Only the electricity wasn't going to be paid for by anybody. So this is a great revenue stream for the power companies. It's cheap, almost free electricity. It's a windfall for them. It doesn't add any more CO2 to the atmosphere. And it's only 44.9% of the way we make electricity in the United States anyway. So the assertion that electric vehicles are polluting is absolute nonsense. It's false science.
Okay. Very good. There we go.
So the next slide is, we've heard this, well, electric vehicles are too quiet. The blind will not be able to notice an electric vehicle, and it's going to cause a pedestrian hazard. And so the Department of the National Highway Traffic Safety Administration, in their wisdom and bloated budgets, decided to conduct a study, a 155-page study, in which they compared a Lexus to a Prius. Both these are Toyota cars, to see which one the blind could detect at low speed, approaching either accelerating or decelerating. And the quote from the study is, in the results reported below, it is clear that EVs are being detected by vision-impaired pedestrians sooner and with better accuracy than internal combustion engine vehicles. To understand this anomalous result, one must be aware that EVs tested emit a faint 5 kilohertz tone with a 10 kilohertz harmonic when they are operating in regenerative braking mode. The same tones can be detected outside the vehicle during acceleration at speeds under 30 miles an hour. Now, above 30 miles an hour, you don't need to hear that tone because you can hear the wind in the tires off the car just like you can in any other car. Mm-hmm. In the study, in the test, 100% of the electric vehicles were detected approaching them by the blind, and only 50% of the internal combustion engine vehicles were detected. They were so quiet.
That's a remarkable finding. Thank you for that. Keep going.
I have the study. I'd be happy. It's posted on our website at mynewev.com, just so people can see this isn't our idea. This was actually done by the NHTSA, and it's a real solid study.
Well, let's say that again. So the website is mynewev.com.
Yeah, mynewev.com.
Very good.
And if we will, anytime the government does one of these big studies, we're going to post it so that the public and other EV companies can make access to it and get past some of these hurdles that we all face together. One of the other things that comes up, and we've heard this in our many trips to Washington, is why not just allow the major car makers to supply the electric vehicles? I mean, let car makers make cars, and let's quit the nonsense here and get rid of all these independent car companies. Well, the answer is, and I'll explain this experience I had with Secretary of Transportation Ray LaHood when I spoke to him face-to-face. I went up to the Congressional Business Summit by invitation and took 400 businessmen from the state of North Carolina, including representatives from the governor's office. And it wasn't a confrontation. It was more of an informational summit. We wanted to inquire of the Secretary what the Department of Transportation was going to do to support independent car companies bringing electric vehicles to the American highway. And, of course, as soon as I said that, the 6'5" tall Ray LaHood looked down at me and said, well, it's electric vehicles. Why don't you just buy a GM? Just buy a Volt. And so everybody kind of laughed a little bit like, nice commercial, Mr. Secretary. And I said, well, be that as it may, we want to know why the Department of Transportation won't level the playing field and allow small business to introduce these vehicles as well. And he simply said, well, because they made the investment. And I let that sit for a couple minutes, and you could have heard a pin drop in this theater with 400 businessmen in it. And I said, well, actually, Mr. Secretary, we made the investment, and we didn't get paid back.
I'm not understanding this, Brooks. So are you suggesting the OEMs are doing what they're doing, and I'm not happy with it either, but they are doing, every major OEM that expects to be around by the year 2020 has an EV program somewhere in the works, whether you're talking about BMW and Mercedes in Germany or whatever you're talking about in the United States or Japan. So they're doing what they're doing, and I'm not thrilled about it either in terms of the pace and the commitment and the sincerity with which they're doing this. Having said that, when you talk to Carlos Ghosn, the CEO of the Renault-Nissan Alliance, he's pretty, he's running at this thing about 100 miles an hour. So so that's one point. My other point is, so they are making the commitment at whatever level. What about, and there's no law that says, when you say you want a level playing field, what exactly are you asking the Secretary of Transportation to do for you?
Well, when it comes to regulations in the EPA, NHTSA, and even in the commerce regulations, large companies can do things that small companies can't do, and I'll be specific. Each of these agencies has a clause which they call the capability clause. For instance, we attempted to sell our trucks to government agencies through the GSA, which is the General Services Administration. It's kind of like a big phone book that somebody in an agency in Atlanta wants to buy a desk. They'll go to the GSA and look up all the available desk suppliers, and they'll order one. So if you don't show up in the GSA, agencies can't find you. It's just basically a giant mall that's administrated by them. Now, for a major car company, it's a simple process. You fill out some paperwork. It takes about 2 weeks to apply. You get it done, and you're listed. Pictures of your vehicle are on there. Prices are on there, and people can order it. But for a small company, you have to put up all the money that it will cost to buy that vehicle for the first 4 years up front as a letter of credit. So let's say we're going to sell a light electric pickup truck, which is a 62 E-Class vehicle, and let's say that they projected that we need to supply 20 vehicles a year for 4 years. So that's 80 vehicles. We are required by the capability clause to produce a letter of credit equal to the price of 80 vehicles and sit on it for 4 years, waiting for the GSA to make an order. That is impossible for small companies to do.
I see. Well,
nope.
I see the problem. It's unclear what to do about that, considering obviously the intent, or at least the ostensible intent of the thing is to make sure that things are available when people want them. In other words, to not have specious, products that don't really exist.
Well, but it happens all the time. I mean, GM filed bankruptcy, Chrysler filed bankruptcy, and their vehicles were not available during that period where they were going through reorganization. Some was 1 month, some was 90 days. So, if somebody orders a truck and they, after the 150-day period, they don't get it, it isn't the end of the world. They haven't spent a penny, nothing. There's no down payment. There's no risk whatsoever.
Okay.
And, of course, the argument was made, well, the GSA's reputation would be harmed if you don't deliver the truck. After what happened in Las Vegas, I don't think anything could harm their reputation. So this is what we, as small businesses, face in the United States. And it's a long uphill battle, but we will make it eventually.
That's cool. Very good.
So then in the next slide, we are not competing against other electric vehicles. I hope every electric vehicle maker that's listening to this webinar today is as successful as we are and better. because together we're not even going to scratch the surface of the automotive market in this country, not for a long time. We need each other, and we need the competition. We need the innovation. Our suppliers need it, and the people need it. But at the end of the day, we are competing against oil. We're competing against gasoline. And it's a cheap fuel because, if you went to Mumbai and you asked a rickshaw driver to take you and 4 of your friends 1 mile for 20 cents, he would laugh at you. Even human power is more expensive than oil. And the simple answer is that internal combustion engines are here to stay. But burning fuel is a 19th century use of petroleum. Petroleum is put to so many better uses that we are a smarter, more efficient, cleaner, I would say more synergistic society, and we deserve to have the option of using some other method of driving back and forth to work, especially when I get to put about $350 a month back in my pocket. In the next slide, we look at this cost of ownership. Here's the stark difference. You got gasoline on the left. Just the cost of gasoline at $3.49 a gallon if you get 20 miles per gallon, you drive 15,000 miles a year, is going to be $2,617.50 just the gas. That's not counting services to your water system and your oil system. On the right-hand side, based on 6 cents per kilowatt hour, which is about the industry average. Some's higher on the East Coast and lower on the West Coast, but it's about 6 cents.
I think the average is between 10 and 11 cents, but maybe this is mine. In the United States.
Well, I don't know. We pay 6 cents in North Carolina, and I think in Washington State it's 3 cents because it's mostly hydroelectric power. So I just picked 6 as kind of a middle line. But that's about $360 a year. That's not all the cost, though, because you got to replace those batteries in about 8 years. And our battery pack costs about $8,500 to replace. You get a slight credit when you turn your old batteries in because we use them in other industries, and we'll let you get some of that cost back. That's about $1,062 a year. So you're at somewhere around $1,382 a year to drive an electric vehicle, which is a 47% savings over internal combustion engines, and the break-even point is about $1.82 a gallon for gas. If you think that anybody's efforts is going to get gasoline back down to $1.82 or less, then you probably don't need to buy an electric vehicle. At the end of the day, you should have a little yellow sticker on your vehicle that says it costs $360 a year to operate this vehicle. That's the simple gist of it. And in the next slide, I just want to show you a picture of our Everest. We call this the electric light logistics vehicle. It's a small cab, a pickup truck bed on this one, which can haul 1,000 pounds, goes about 100 miles between charges. At the end of the day, in a summer day, you probably get 140, 150 miles a day out of this truck, charging it up in between trips. And of course, it has airbags, and it drives just like a gasoline-powered vehicle, and the price is around $25,000. That's affordable because, as I said, our competition is not electric vehicles, it's gas-powered vehicles. So we got to price the same, look the same, and drive the same. In the next slide, you'll see our current competition on the left, which is a low-speed vehicle. It goes 24 miles an hour. It does not have air. It has no heat. It has a 20-mile range. And if you distribute it correctly, it'll carry about 500 pounds. Of course, our vehicle has twice the payload, 5 times the range, heat, air conditioning. It's legal for highway use, and it'll go 85 miles an hour. And it costs about $3,500 more. And,
well, this is remarkable. As a matter of fact, the way I introduced you in the emails that I've written about this is that I think anybody can build an electric truck for $70,000. That's the problem with Phoenix, and the reason there is no Phoenix electric truck is that it's $70,000.
And it weighs 6,100 pounds.
I'm sorry?
And it weighed 6,100 pounds.
Right. So that's not the issue. The issue is, can you do this affordably? And I guess the answer is yes. Certainly that would be your claim, correct?
Yeah. The answer is that you cannot do a lot of luxury and a lot of exotic things in an electric vehicle where you can't control the costs.
Mm-hmm.
Fortunately, there's good competition in things like batteries, controllers, and if you try to stay within the automotive industry for your other components, so you can find spares at AutoZone and the local dealerships, you can bring your costs way, way down. You're talking about introducing a vehicle with 4 electric motors, 1 in each wheel, with dual controllers and regenerative braking and all this technology for which you have to offer spare parts for the next 20 years, and your costs are going to go through the roof. We had a design criteria to build a vehicle that would base out at $25,000, and that was it. So it doesn't have carpet, it has rubber floor mats, but you could do anything to this truck that you can do to a Ford Ranger. You can put sport wheels on it, roll bars on it, fancy lights, whatever you want on this truck, and make it whatever you want it to be. But we felt that getting the utility into people's hands is the market, and I think we're right on the money.
I think you're right on the money, too. Do you mind, I'm sure there are aspects of this drivetrain that are proprietary, but do you mind telling the audience as much as you feel you want to about what's under the hood, as it were?
Well, there's nothing under the hood.
I'm just using it metaphorically.
Traditional drivetrains use an inline transmission with a drive shaft going back to differential, going to wheels. And anyone that knows anything about mechanical engineering knows every time you make a right angle turn with gears, you lose efficiency. Hence, back in 1976, when Volkswagen went from the rear-wheel drive, rear-engine air-cooled to the front-wheel drive engine with a front motor, we saw a huge increase in performance with only a 10 horsepower increase in power. We went to a 78 horsepower motor from a 68 horsepower motor, but everyone will agree that the Volkswagen Rabbit would run away from the Volkswagen Beetle. And the reason was because there was no right angle move in the mechanics. The drive shaft, the cluster gears in the transmission, the CV joints were all parallel to one another. So we use that technology to make sure that all the drive in the vehicle from front to back is all parallel to one another. And that makes it very, very, very efficient, mechanically speaking. The other is to do away with batteries that overheat when they charge up. So we use a very reliable battery management system. We don't use high amperage inputs like 75 amp inputs to the batteries, which can cause overheating. We charge at whatever line voltages are, 120, 240 volts. We maintain air-cooled system throughout, so you don't have to maintain a radiator and hoses and pumps and all that stuff. The idea was to make a simple, reliable, rugged, top-performing system with the least number of failure parts. And so that's how we were able to hit this target.
Uh-huh.
In the next photo, you'll see the next 3 vehicles that we're looking at. On the left-hand side, top and bottom, is the Raven. This is a 1,700-pound car. It will go, and it only has a 1,600 cc motor in it in its original design, and it'll go 0 to 60 in 2.4 seconds. But as an electric version, this is a fun car to drive. If I was commuting, I think this would be a head turner. It's kind of a combination between a Prowler and I was going to say what's the other Chrysler car that's the hot rod?
I have no clue.
It just escapes me at the moment. Anyway, it's a combination of those two cars, and it's an aluminum space frame car with carbon composite panels, so it's kind of an innovative frame design. The upper right is called the Hopper. This car was originally designed in France. All the green parts that you see are composite, so they can change from model year to model year, making it even more sporty or less sporty looking. The silver parts are steel. This car has already undergone European crash standards. As you can see, the 2 steel bars that make up the lower frame there to protect you from side collisions. It's a fun car to drive. And in the lower right-hand one is a more futuristic that comes from our joint venture partner with the sliding doors and a really wide open interior. It's a nice vehicle, and we'll tell you more about that when it gets ready to launch. So the final slide is, go ahead.
Sorry?
No, I interrupted you. Go ahead.
Well, I was just about ready to close off. I mean, that's our last slide.
There's one more.
Well, I don't have
one more slide.
Why don't
you don't?
Because I don't have it.
Oh. That's interesting. It left off the last slide. Or it might be all black because the pictures don't show up. The last slide is all the supporting partners that we have. Of course, we have Leilani Munter, who's a NASCAR driver, is our official, public driver. Esther Vari, which is our Indian partners, and we're members of the EDTA and the North Carolina Military Business Center. So we have lots of demand for our vehicle, and I think if the electric vehicle manufacturers and buyers out there will just, stick to their individual niches, I think they can be very successful in this industry.
Great. Well, I think, in summary, there are a couple of things that strike me about this, but I think the fact that, I go back to Bob Lutz, the ex-co-chair of GM, who said famously that this will never happen from people outside the industry. And, of course, that was a considerable challenge and going out on a limb. Having said that, there certainly is evidence that there's enough complication in the automotive industry that if you think you're going to come at this thing from the standpoint of some completely disrelated subject, this is a little harder than it looks. I think the interesting point here...
Yeah, and I was going to say, Bob's right. That's why, we use contract manufacturing that's experienced at building cars. We're using, seasoned veteran engineers and assembly people and tools that are proven. He's absolutely right. You cannot build an electric car company in a garage or go buy an old plant and just hope to start up a car plant. You'll be 10 years and $500 million in development, and you still won't get there. You must use.
And I do think that there's ample evidence that he is correct based on what we've seen over the last few years and the kind of shakeout in this. I've certainly noticed that. I try to attend at least one EV conference every year, and you certainly can see the shakeout, the consolidation, and I suppose, the vindication of what he said there. And I guess my point is the fact that you come from this industry, I think, is telling, and the fact that this is not aimed to be all things to all people. It's aimed to be an extremely functional, low-cost, pragmatic solution to a real problem. And as I always say, how the whole thing about electric transportation, how do you sell electric transportation to 300 million Americans who may be skeptical of it, seeing what they are, what they're exposed to from Fox News and so forth? One thing that I often say is that this is the most patriotic thing that you can do. If you really do care about the United States and you do think this is a great country, there's so many things that are just so completely wrong about what we're doing with respect to borrowing an incremental $1 billion a day and sending it to people who want to kill us. There's something so fundamentally and so obviously wrong about that I submit that this electric transportation phenomenon is the most patriotic thing that you can conceive of.
I think you raise a very good point there. And the other, sales aspect is not necessarily the driver of the vehicle, but the owner of the vehicle. For instance, if you go to the commercial market and you talk to the accountant and not the driver of the vehicle, and you say, how much are you spending on fuel? Let's just talk a little municipality with, say, 30,000 people in it. You'd be really surprised to learn that they spend about $9,000 to $10,000 a month on gasoline for all the little vehicles that they drive around this little town.
Right.
Well, every time fuel goes up, they have to increase taxes, property taxes, on the people that live in that community in order to drive all the vehicles, pick up leaves and read meters and all that stuff. If they went to electric, they could save all that money, hundreds of thousands of dollars a year, that they do not have to get from taxpayers. And literally every 10th vehicle they buy is free because they don't have to buy fuel. And they have a very predictable cost model. If gas goes up $1 a gallon, like we've ever seen that happen,
Right.
it doesn't change your budget that you planned on 2 years ago. But it's the unpredictability of fuel costs that has created the inflation that you're seeing at the grocery store. Nothing more.
It's exactly right. Very well said. Well, that's about all the time we have for today. Brooks, thanks very much. I knew this would be entertaining, and it certainly lived up to its billing. Thanks again for doing the show with me.
Well, I appreciate it so much. And I'm going to send you the PDF version of this so you have all of the graphics.
Okay, very good.
Post.
All right, thanks. Talk to you again.
All right?
All right.
Thank you. Bye-bye.
All right, thanks. Bye.